Ever since the first atomic bombs were dropped by B-29 superfortresses on Japan in 1945, the U.S. Air Force has seen the manned bomber as a crucial part of America's nuclear deterrent. Perhaps the ultimate bomber is the B-2 Spirit. It may well be the last of its kind. The B-2 development program was initiated in 1981, and the Air Force was granted approval in 1987 to begin procurement of 132 operational B-2 aircraft, principally for strategic bombing missions. With the demise of the Soviet Union, the emphasis of B-2 development was changed to conventional operations, and the number was reduced to 20 operational aircraft, plus one test aircraft that was not planned to be upgraded to an operational configuration. Production of these aircraft has been concurrent with development and testing. The first B-2 was publicly displayed on November 22, 1988, when it was rolled out of its hangar at Air Force Plant 42 in Palmdale, California. Its first flight was July 17, 1989. The B-2 Combined Test Force, Air Force Flight Test Center, Edwards Air Force Base, California, is responsible for flight testing the aircraft as they are produced. The B-2 Spirit is a multi-role bomber capable of delivering both conventional and nuclear munitions. Along with the B-52 and B-1B, the B-2 provides the penetrating flexibility and effectiveness inherent in manned bombers. Its low observable or stealth characteristics give it the unique ability to penetrate an enemy's most sophisticated defenses and threaten its most valued and heavily defended targets. Its capability to penetrate air defenses and threaten effective retaliation provides a strong, effective deterrent and combat force well into the 21st century. The blending of low observable technologies with high aerodynamic efficiency and large payload gives the B-2 important advantages over existing bombers. Its low observability provides it greater freedom of action at high altitudes, thus increasing its range and a better field of view for the aircraft's sensors. Its first rollout and testing was given an enthusiastic response by the workers who helped construct the ship. The B-2's low observability is derived from a combination of reduced infrared, acoustic, electromagnetic, visual, and radar signatures. These signatures make it difficult for the sophisticated defensive systems to detect, track, and engage the B-2. Many aspects of the low observability process remain classified. However, the B-2's composite materials, special coatings, and flying wing design all contribute to its stealthiness. The B-2 has a crew of 2 pilots, an aircraft commander in the left seat and mission commander in the right, compared to the B-1B's crew of 4 and the B-52's crew of 5. A chase plane keeps an eye on the new ship and watches for any external signs of trouble or problems that might develop in the test flight. After all, this is a ship that cannot fly without its fly-by-wire system. This involves 4 redundant computers, each in continuous communication with the others. Should one of them fail, the other 3 will shut it down and take over its function. In the unlikely event that all 4 should ever fail, the B-2 will plummet like a stone from the sky. The flying wing is inherently unstable, and without the computers constantly adjusting its trim, it has all the flight characteristics of the proverbial lead balloon. But today, the initial test flight went off as smooth as silk. And congratulations are tendered all around to the pilots and to the designers by the Air Force, which has been waiting for just such a ship. The F-111 and the B-52 had handled the American Air Force nuclear deterrent almost exclusively prior to the B-2. Both ships could carry and handle not only nuclear bombs, but conventional PGMs, or precision-guided munitions. The on-again, off-again B-1B was also suited for these tasks and almost concurrent in its production schedule with the B-2 development program. Congressional critics quite understandably wanted to know why the Air Force needed both of these very expensive aircraft, especially given the fact of submarine-launched missiles. The B-2, although not supersonic, could theoretically sweep through Russian radar and deliver its nuclear bomb load, providing a new complement to the sub-launched missile fleet. The special design of the B-2, combined with the unique skin of the aircraft, make it almost, but not totally, invisible to radar. The whole B-2 design was based upon this unique radar and heat-absorbing skin. Its engines have very reduced emissions to keep the infrared profile low. But a problem has since developed with the special coating applied to the skin of the ship. Northrop was embarrassed by the tendency of the coating to peel away after being subjected to no more stress than a rainstorm. Critics have called the B-2 a hothouse airplane and unable to withstand the stresses of the real world. It's an ongoing problem that Northrop is addressing even now. The Russian Su-27 is one of the latest fighters to come off the Russian production lines, given special avionics to help it see the stealth bomber at night, the only time it would be flying. For the Soviets to counter the B-2, it took a major revision of their air defense systems. Having to worry about strategic bombers sneaking in was an idea that seemingly had become obsolete. But the B-2 made the problem real again. Billions would have to be spent by the Russians to counter this new threat. By the end of the 1980s, the Soviets simply didn't have the money to keep up with the West. With the extreme cost of the B-2 program, each plane had cost hundreds of millions of dollars, made it a weapon system that the United States itself could barely afford. Indeed, some would argue it can't afford it now. But it's out there now, a fact on the ground and in the air. The B-2 Spirit is a very expensive, strategic, long-range, multi-role bomber, and tests show that with its low observable stealth characteristics, the B-2 is the most survivable aircraft in the world. One of the 6 flight test B-2s remains in an extended testing program at Edwards Air Force Base, California. "16 B-2s have been delivered to the operational fleet at Whiteman Air Force Base, Missouri. In their first 3 years of service, operational B-2s achieved a sortie reliability rate of 90%. The B-2's low observability means that it doesn't need an armada of support aircraft to accomplish a mission, and its large payload allows it to do the work of many smaller attack aircraft. The Air Force has published a representative mission scenario showing that 2 B-2s armed with precision weapons can do the job of a package of 75 conventional aircraft. Only 4 B-2 crew members are put at risk in this mission, compared to 132 in the conventional aircraft package. The B-2 can fly more than 6,000 nautical miles unrefueled, and more than 10,000 nautical miles with just one refueling, giving it the ability to fly to any point on the globe within hours. The B-2 can carry up to 20 tons of conventional and nuclear ordnance and deliver it accurately under any weather conditions. Significantly, a single B-2 can deliver 16 one-ton near-precision munitions. The flying wing concept was very close to the heart of Northrop founder Jack Northrop. He was one of the pioneering giants in aviation. As early as 1923, Northrop had been convinced that the flying wing, in which the aircraft carried all loads and controls within the wing and dispensed with fuselage and tail sections, was the next major step forward in aircraft design. This is the YB-49. It was the successor to the propeller-driven BB-35 developed during World War II. The YB-35 project was bedeviled by problems and mishaps, but the Air Force still considered the flying wing concept as having merit. On June 1st, 1945, a contract ordering the conversion of 2 of the YB-35 flying wings into jet configuration was issued. The 4 Wasp major engines of the B-35 were to be replaced by 8 4,000-pound thrust Allison J-35A5 turbojets buried inside the wing, 4 on each side. The engines were to be fed by intakes cut into the leading edges of the wing. The designation given to the jet-powered flying wing bomber was originally supposed to have been YB-35B, but this was changed to YB-49 before the first flight took place. Since the addition of jet power promised a marked improvement in the performance of the flying wing, work on the YB-35 project was abandoned, and plans were made to convert all the YB-35 airframes beyond the first to YB-49 configuration. The crew of 7 were housed entirely within the wing center section, with the pilot seated underneath a large bubble canopy near the wing leading edge. For long flights, an additional off-duty crew of 6 members would be carried in quarters in the tail cone just aft of the flight section. Conversion of the YB-35 to the YB-49 configuration was originally scheduled to be completed by June of 1946. However, this schedule slipped by more than a year because of unforeseen problems encountered in adding fins to the wings. The first YB-49 took off on its maiden flight in 1947 from the Northrop Field at Hawthorne, California, piloted by Northrop's chief test pilot, Max Stanley. At the end of the flight, it landed at Muroc Air Force Base, where it was to carry out its test program. It was later joined by the second YB-49, which flew for the first time in 1948. Over 20 months of flight testing were carried out on the 2 planes, with hundreds of hours of flight time logged in the ships by both Northrop contract test pilots and Air Force pilots. A maximum speed of 520 miles an hour was achieved, and a service ceiling of 42,000 feet was attained. A normal 10,000-pound bomb load could be carried for an estimated 4,000 miles on 6,700 gallons of fuel, less than half the range of the piston engine B-35. In spite of the added rudders and wing fences, the YB-49 design still encountered some stability problems which were never fully corrected. On April 26, 1948, the first YB-49 achieved a milestone of sorts, the aircraft staying up in the air for 9 hours, 6 of which were above 40,000 feet. This is believed to have set an unofficial world record for that period. On May 28, 1948, the second YB-49 was turned over to the U.S. Air Force. Only a few days later, tragedy struck. On the morning of June 5, 1948, it crashed just north of Muroc Dry Lake. The pilot, Air Force Captain Glenn Edwards, and all 4 members of the crew were killed. What caused the crash is not known, but it was suspected that Captain Edwards managed to surpass the red line speed of the aircraft while descending from 40,000 feet, causing the outer wing panels to shed and the aircraft to disintegrate in midair. Muroc Air Force Base was renamed Edwards Air Force Base on December 5, 1949, in honor of the late Captain Glenn Edwards. In spite of the crash, the Air Force still had sufficient confidence in the YB-49 that they continued with plans for the conversion of 9 of the remaining 7 YB-35 airframes. They were to be altered to a basically similar RB-49B strategic reconnaissance configuration with 8 jet engines, with another airframe to be used as a static test vehicle. In addition, orders were placed for 30 new RB-49s to be built from scratch. Many deficiencies turned up in the second series of tests. The test pilots complained that the aircraft was extremely unstable and difficult to fly. The J-35 turbojets of the YB-49 were extremely thirsty for fuel, and the jet-powered ship had only half the range of the YB-35 that preceded it. They also maintained that the YB-49 was completely unsuitable as a bombing platform. It could not hold a steady course or a constant airspeed and altitude, and that there was a persistent rocking motion and yaw, which tended to upset the bomb sights. The problems encountered were enough to kill the program. Politically, the B-2 has been controversial since the beginning of its development, because much of its cost was predicated on the needs of the Cold War, To a degree, its new missions, particularly conventional ones, must be developed in order to maintain support for the project. The Air Force has worked hard to achieve both an ongoing nuclear role for the B-2 as well as a conventional one. The B-2 has had to compete for scarce Defense Department dollars during its test phase. Virtually every other major weapons program in the American military is also short of funds. The B-2, because of the enormous amount of money required for each plane, makes it a constant target for those seeking economies in the defense budget. Still, its advocates say the B-2 is a unique airplane, capable of performing missions no other weapon system can perform. There is still the ongoing problem of the peeling skin. The plane needs constant maintenance in this regard alone. Whiteman Air Force Base, Missouri, is the B-2's only operational base at the moment. The first aircraft, Spirit of Missouri, was delivered December 17, 1993. Perhaps the B-2's single most difficult hurdle out of all that it has faced in order to become operational is the collapse of the Soviet monolith in 1991, barely a decade after the flying wing concept was revived and its further development assured. Curiously enough, the Air Force is still fighting to keep the B-2, after having decided it does not need or want any more F-117 Nighthawks, which preceded the B-2 in development. Congress has recently been asking another embarrassing question of the Air Force in Northrop. One of the hardest things to figure out is why the skin coating on the F-117 is not peeled as it has on the B-2, especially since both are made out of the exact same material. Computer simulations have not yet found the solution. Helicopters have been painted with the material as an experiment, and to date no peeling has yet been noted. The B-2 has also to compete with the newest Air Force superfighters for scarce funding. Now that the B-2's main mission and reason for existence has been obviated by lack of any conceivable strategic threat, the Air Force has been stressing the big bomber's conventional capabilities and how it might be used in small wars like that fought in 1991 in the Persian Gulf against Iraq. Although that was not really a small war when you consider that 500,000 men were under arms. Mission specialists at consoles are always on the lookout for any new missions the B-2 would be particularly adept at fulfilling, like the addition of cruise missiles to its armament. Looking more and more like overkill in today's world, the ICBM still remains the greatest strategic deterrent the U.S. has. The cruise missile, on the other hand, with its ability to be launched miles from a target, is becoming a preferred means of conducting deep strikes. The F-117 proved beyond a doubt the whole concept of stealth during the Gulf War. It led off the attack against Iraq and destroyed all of its assigned targets without the loss of a single ship. Defense workers and contractor employees, of course, hope that the B-2 will continue to enjoy funding by the Congress. Even before November of 1988, when the first one rolled out, they have been enthusiastic supporters. They want to keep their jobs. Many of today's defense workers are sons and daughters of those who were there in the beginning of the flying wing concept. Most of them are involved in the day-to-day process of trying to correct the remaining difficulties the B-2 faces, such as the peeling paint problem, and ergonomic placement of some of the ship's avionics. All of this involves heavy-duty computer modeling and simulation. It seems hard to imagine that after all the design work that has already gone into the plane, there could still be major improvements. But the search for better answers never ceases, even when what exists works perfectly well. The old adage, if it ain't broke, don't fix it, is foreign to Northrop design teams. Anything that will improve the stealth characteristics of the ship or will help it defend itself if attacked is constantly chewed over and thought about at all levels of the design production team. If a new solution is found that works better than the one in place, the company then checks with the Air Force procurement team for authorization to incorporate it. Some changes make it, others do not. Often it's a question of money. How expensive will it be to incorporate the change? What else will have to change as a result of making the first change? This is not an easy process, and burnout is a mental challenge everyone faces in the quest to make the B-2 the best it can possibly be. Often the ideas coming out of the skunk works have ramifications that have nothing to do with the practicalities of changing the B-2 itself. Many of the ideas can also be used as ammunition to counter the plane's critics in Congress. Satisfactory explanations of why this or that gadget or other new piece of equipment is needed can sway decisions on Capitol Hill. Design specifications are printed out and distributed to all members of the team, who then weigh each new proposed change. They then must file their own reports on what the change will mean for their department. All systems must integrate as seamlessly as possible. The pilot and his weapons officer have enough to worry about on a mission without the added burden of something unforeseen going wrong with the aircraft. With all 4 computers and the fly-by-wire system functioning normally, the ship is a very stable bombing platform that is practically invisible on radar. Three of those computers could fail and the B-2 could still fly straight and steady. But if that were to happen, the crew could fly on to complete the mission, no doubt with extremely elevated heart rates. If the 4th one goes, the only ace in the hole is ejection, possibly over hostile territory. That is why the design team of the B-2 is so hard at work on a continuing basis. The possibility for disaster must be kept at an absolute minimum. The B-2 remains in testing. It will be part of the American Strategic Bomber Force for many years. To a degree, it is an airplane in search of a mission, but there are many in the Air Force that are glad the plane exists. For when that mission arrives, the B-2 and its crews will be ready.